Hi everyone, thanks for coming to this session. It is really exciting for us to be here and launch our project. Um, so this is a collaborative project between Hunter College and BetaNYC. So I think it is a home for BetaNYC here. So we're just we're using a special ticket. I didn't pay for registration because I'm not applying with NYC. That's one of the benefits. Well, our project is about urban heat. Uh, uh, this project was partially funded by NASA, and we had some other partners. We had some colleagues from Penn State University. We had many students from Hunter College that worked on this project, and BetaNYC basically did the website design for us, data visualization, the best practices on those things. It was a great collaborative project. We met every basically week to talk about what we need to do, things to need, that needs to be improved. So we are here to workshop the portal. So what we're gonna do, have a, we're gonna explain what the portal is offering, and then we can work together with, exploring your neighborhood, the city, and understanding how the portal can provide some information. And from BetaNYC, Ashley, if you want to introduce yourself.
Hi, my name's Ashley. While I was at BetaNYC, I was the Chief Technology Officer. I've since moved on to another role, but I was leading this project on the beta side with website design, data visualization, and leading the development of the project from our side. Yeah.
I'm Mehdi Heris. I am the project PI, so at Hunter College, I teach city planning.
Andrew Kittredge, current Civic Innovation Lab Director. I just want to preface this, I did not work as much on this project on the BetaNYC side as my colleagues here, but I did actually work with Mehdi when I was a student at Hunter College doing my master's in geoinformatics. Mehdi was on my thesis committee, and I worked as a research assistant for him, and contributed a little bit to some of the data you'll see visualized today.
Hi everyone, my name is Lin, and I'm the NYC Front-End Development Associate. And for this project, I was responsible for front-end website and data visualizations development. Yeah.
Thank you. We don't have Z here, but Z also is a BetaNYC champion, and he actually also helped a lot.
Also, Haley, shout out to Haley, who did the front end kind of UI UX design. Yeah.
Wonderful. So let's get started with Urban Heat. So this is the portal. We just wanted to put it up front. Our portal provides multiple different layers about urban heat and the heat distribution, and how we can explore these things. We have weather station data, we pull satellite images, and the layers that we have downloaded, is all curated here. And also we had some data that we simulated and modeled here. As you probably all know, urban heat is a phenomenon that we are interested because can make cities much warmer because of impervious surfaces, buildings, the heat that we are absorbing in the urban area. And so urban areas can be warmer up to 4 to 5 degrees Fahrenheit than the natural environment around that. So, and if you add the general warming that you're experiencing, urban heat eventually can be a serious issue. Every summer, we're gonna deal with this. We're gonna deal with this more and more in the future, and we need to be prepared for intensity of heat in our neighborhoods. So this project, we made very clear that you want to work with advocacy groups. And we didn't want to create a portal that educates the general public because such portals, such websites are already available and are already created. We wanted to create something that advocacy groups can come and learn about their neighborhoods, about their constituents, and use that for their advocacy process. We've worked with multiple advocacy groups in the city. We interviewed them. We had focus groups with them, and to understand their processes, how they are interested about urban heat, and how they want to use urban heat data. Also, we worked with local governments, local government agencies. Specifically, we worked with a mayor's office of climate and environmental justice, and they also provide us really considerable and kind contribution in terms of how they might use this portal for their processes. So we have a survey, and I actually have also a hard copy of that. We prefer an online version if you are comfortable with scanning, going through the questions. The questions are super simple, but also I have some hard copies in case someone wants a hard copy survey. We'll take about 5 minutes and then we'll continue. Well, if you want to get urban, some data about urban heat, to learn maybe where, which neighborhoods, which locations are warmer than other ones, or how it is changing, there are multiple resources that you can currently go. You can download weather station data. For example, New York City has multiple weather stations. For example, Central Park has a weather station that has open data. That's really good. One of my favorite places is Wonder Map. These are some weather stations that people maintain. Often gives you some good understanding of what the temperature is in the city when you go. You can also click on those weather stations and see, for example, the historical data. But all of that, just requires a lot of work. There are also APIs that these days you can use and program and systematically get the temperature, precipitation, all sort of different weather information. The surface temperature that you mentioned, right? You can download this from Landsat. You can download from multiple resources. You can download, for example, level 2 collection 2, which comes with a prepared surface temperature, which is really helpful. But you still have to do some processing because the layer that you are downloading is digital number, and you have to convert that to a float number, eventually to Fahrenheit, centigrade, whatever you are using. So some data processing is still required. Not huge, but it's still identifying a cloud-free image, all of that. So you have to go through all of those. For an expert in basically remote sensing or GIS or urban data, it is not too difficult. But for our audience, which is advocacy groups, that can be still a complicated task. So our data portal provides the status of urban heat, and we mainly provide 3 data sets: weather stations, the data from weather stations, surface temperature maps or layers, and mean radiant temperature map. We also have air temperature and air heat index that we modeled, and we provide that also as some supplementary layers. Also, we want to provide all those layers that can be used as heat mitigation resources or heat. Basically, for example, tree canopy. Basically, it is an intuitive knowledge that trees can help with heat mitigation. Also, cool roofs, another important strategy to keep cities cooler. We want to know where the cool roofs are. Permeable surfaces is another important factor you can basically use for heat mitigation. So these are some of the maps that we have. These are the weather station data. Is that
Bad.
Yeah, the projector, basically you cannot see the background. But these are the weather
Imagine a
stations that
map
we
of
have.
New York.
This is the surface temperature layer that is nothing basically. It's
What?
yeah. So yeah, these projectors are not the greatest.
It looks really good up here. Though.
Yeah. And this is the mean radiant temperature that provides the thermal comfort in the urban environment. We created this layer using Solveig software, and this is 1 meter resolution. Provides it is modeled based on the trees, buildings, and if for a typical summer day, which was July 15, thank you.
2 p.m.
2 p.m. So we are planning to generate this layer for more hours. So we could have basically a more, you probably don't see this at all. These are cool roofs. But we're gonna workshop this. So for those of you that have laptops or maybe tablets, we are more prepared for more data visualization here. So trees, we took the tree cover data of the city or land cover data of the city, and we separated the trees because again, the land cover data of the city is 6-inch resolution, really great resolution, right? But it is very difficult layer to deal with. If you want to download that, it is many gigabytes of data. It is, I think, when you unzip it, it is about 17 gigabyte or something like that. So heavy layer, using that is not easy. And then taking some cells out of that, like permeable surfaces or land covering cells, it is still heavy lifting. So we provided permeable surfaces, tree cover, and we downsampled them and provided them in this portal. So because you don't see many of these layers, I'm going to just really focus on a few things. This is the data structure that we have. We have our outdoor heat exposure that is calculated from our static factors. And why we have static factors and dynamic factors. The static factors or the static layers are those layers that are tied to the built environment. And it is basically, they are the function of built environment. For example, surface temperature. Surface temperature often is a function of the type of surface that you have. If you have asphalt, if you have, a dark roof, usually it's going to be warmer than the landscape around it. Trees, those places that with permeable surface or grass, they are cooler than the landscape around it. So and landscape is not really changing very fast, right? So we have those as static variables. So tree cover, cool roofs, permeable surfaces, surface temperatures, and mean radiant temperature that comes also out of those. We call those static layers. And then we have dynamic layers. Why? Because for example, air temperature. Why did we call it dynamic? Because it is really the function of landscape, but more importantly, the function of wind and air movement in the city. And that is very variable. From 1 hour to another hour, you can have wind coming from different angle, from different orientation, different speed, and it is moving the air around in the city. So it's mixing, and a neighborhood that it is warm today at noon might not be warm, for example, at 2 hours from today. It depends on the wind direction. It depends on the wind speed. If those are remaining the same, then you can say yes, that those relationships are remaining the same. But that often is not the case. So we have these, and then we calculated outdoor heat exposure out of the static factors. Simply, we just got the average of those factors, or we scored them between 1 and 5, and we got the average of those. And then we also created a model that uses the surface temperature and uses the weather stations that we have in the region, we used many hours and many days of the available data. We trained some machine learning algorithms, used the random forest model to understand the patterns of how the surface temperatures around those weather stations are affecting the air temperature of those weather stations. We got the cells that were specifically on the upwind of the weather station. We got the wind direction and wind speed, and we were able to incorporate the wind data as one factor that can predict the air temperature and the way it is moving around. So because it is based on wind, we call it dynamic layer. So we have all these layers that eventually creates an air temperature layer like this. This is, you cannot find air temperature raster in other places. That's not a data that you can download. But for any day that we were able to download surface temperature, we have about 27 of them. We were able to simulate the air temperature.
Okay, so when you arrive to the Urban Heat Portal, as Mehdi said, there's kind of like, we really wanted to feature, put the data to kind of frame it for advocacy groups and local government. So really the goal is for anybody who wants to know more about urban heat data, to be able to come here, explore the data, maybe learn something about your neighborhood, or be able to navigate and find more information about urban heat through this website. So we have a couple of visualization techniques. A lot of it is, of course, in the maps that Mehdi has been explaining. So really the kind of most important index that we're putting forward in this Urban Heat Portal is the Outdoor Heat Exposure Index. This is actually different from the Heat Vulnerability Index because this considers only external environmental factors. So what does the kind of like, what is the environment, the urban environment like? And how does that affect like your urban heat in your exact area, versus the Heat Vulnerability Index kind of focuses more so on the demographic vulnerability of how many people may be affected by like heat stroke or heat-related illness and death. So the Department of Health puts together that Heat Vulnerability Index to look at kind of socioeconomic vulnerability in terms of age groups, and like the ability to kind of be resilient to finding, places of cool like AC or being able to afford to deal with those circumstances. But the outdoor heat exposure really only focuses on those external like environmental factors. So again, as Mehdi mentioned, you can kind of navigate through the portal. You can toggle through each of these data sets that are aggregated to the neighborhood tabulation area level. So these are geographic boundaries that line up with census data and the same boundaries that can be combined with the Heat Vulnerability Index. So you can do your spatial cross-analysis with the Heat Vulnerability Index and the Outdoor Heat Exposure Index. So the Outdoor Heat Exposure Index contains all of these static factors. So again, Mehdi kind of described that static factors are things that describe the environmental conditions. So how much heat radiates from the building surrounding or the objects in the space. And that's kind of affected by maybe the tree canopy coverage or the materiality of the building. Like if it's a concrete or brick building, it's going to absorb more heat and therefore kind of like retain that heat and transmit more in that area. Or surface temperature. So again, like about materiality, what areas retain more heat, or if it's kind of grassy or more vegetated areas, those places will stay cooler because it can retain water. The cool roofs are like dependent on specific locations and maybe we can zoom in here. Is that better?
Yeah.
Yeah. So you can see kind of at a building scale, the dark areas are places that have cool roof areas. So that's kind of defined as any materiality with a reflectivity value of 60 or greater. So it's kind of lighter colored materials with greater, like less albedo effect, more.
Reflectivity.
Yeah. So if it's a lighter color, it'll reflect more light and retain less heat, versus if it's a darker color, it's going to retain more heat. Let's see. We can go through tree canopy. Again, this is all of these data layers are, again, like neighborhood aggregated, or you can kind of click to toggle the exact raster data. So specifically, where are those trees in your neighborhood? And as well as permeable surfaces. So again, let's see. We are over here in Hunts Point, and you can kind of toggle between the raw data or the neighborhood data. So if I go back to the outdoor heat exposure index and I want to better investigate all of those different factors, so you can see as I move the tooltip over, you can see the breakdown of this overall like score. So it's a score of, it's an index from 0 to 5, 5 being kind of the highest and 1 or being kind of a low vulnerability score. So if you click on your neighborhood, you can see this kind of neighborhood profile, and it'll break down all of those individual like factors that compose the outdoor heat exposure index. You can see the kind of score breakdown, and I think this screen size is quite small, but maybe you can, let's see if we can zoom out. Ooh, that is better. Awesome. Yeah. Maybe that's too far, but so we can see this highlighted here. So right now, the overall outdoor heat exposure index for Hunters Point in our current neighborhood where we're at here at CUNY School of Law is quite on the higher side relative to the New York City average and the Queens average. So right now we kind of have a score of 4, but we see that the city average is a score of 3.2, and the borough of Queens has also an average of 3.2. You can use this to kind of toggle between, other neighborhoods and other areas. So if we wanted to look at Williamsburg, we could do that, or take a look at, the other boroughs as well. So here's Staten Island, and this one's kind of highlighting the neighborhood Arden Heights. So you can kind of explore this and see the ranking of all of those neighborhoods up against kind of those city averages and the borough averages, just to get a comparison to see if your neighborhood is kind of performing relatively better or relatively worse, needing more, points of advocacy to say, hey, we want to plant more trees because it'll mitigate urban heat in our neighborhood. You can say, let's take a look at how much canopy area we have in this area. And this one in particular is kind of above the city average. But maybe if we were kind of clicking on the map to another area, say somewhere in Manhattan, I would expect to have much fewer trees in Midtown. And you can see here, Midtown Manhattan is kind of at the highest vulnerability because it has the least amount of area. It says that there's kind of 3% of that neighborhood's area covered by tree canopy here. Okay, so that's one aspect that you can explore, the kind of outdoor heat exposure index. The other main data set, as Mehdi mentioned, comes from the weather station data. So this is variable data that depends on wind speeds and wind directions and will change on like a per hour or date basis. We have data aggregated for every year between 2013 to 2023. And again, you can kind of use the portal to kind of navigate through and click on one particular weather station. So if we could click on the kind of Upper East Side, you can see the average the maximum daily air temperature and minimum air temperature values for all of the summer days between May 1st and September 30th. These color bars here, they indicate how many days based on the degree of, the temperature would qualify for an extreme heat event. So that means, for example, any day that has projected temperatures above 95 degrees Fahrenheit, there would be kind of a heat advisory warning so that people know to be aware, stay hydrated, check on your neighbors, go find a cooling center so you can stay cool during those hot days. So there's kind of like 3 degrees of this heat advisory definition. The yellow is kind of the most mild, so it's like 95 degrees and above. These are very loose definitions, but you can kind of like go through the portal and get the exact definition for what qualifies for that. The second one, which is orange, is the National Weather Service Heat Advisory. So that's anything that exceeds 100 degrees Fahrenheit. And if the minimum, evening time temperature does not dip below like 75 degrees. So if it never truly cools down and then it continues to be hot again the next day. Again, I think I'm familiar with this data set now, and I recall that 2022 was extremely more of a hot day, a hot year. And then the red one is like anything that exceeds 105 degrees Fahrenheit. So that's very, very extreme for our human bodies to handle high heats. So those are the days that we need to be most cautious, and people are the most vulnerable for heat related illnesses.
Can I add something here?
Yeah.
So this profile is about air heat index. So and the other tab is air temperature.
Oh yes. Sorry. Yeah.
The difference of air temperature and air heat index is the air heat index is the combination of relative humidity and temperature. And that is the index that is being used to call heat advisory days. That's why we have 2 tabs here. One is calculated based on the Fields light, which is the combination of RH, or relative humidity, and temperature, and the other one is air temperature. These are quite interesting because for every year you can see these are the historical average lines. So you know that historically, for example, for August 1st, that's the maximum temperature that we usually have, and that's the minimum temperature that we observe for those days. And that specific year, for example, you can see how many days you were above that average and how many days maybe you might below that average. This is really quite interesting to explore and whether a station that is nearby, right? And again, for us was just we want to curate the data for people to be able to use it very easily, very quickly. And you can download the weather station data, of course, but visualizing that, getting all that insight, how many of those they were heat advisory days, and those are relatively complicated. So we just try to move the data one step forward for people to be able to use it very quickly for their projects, processes, could be policy making, could be just understanding how different years are different. 2022 was a warm year, but we also have some other years that are cooler. So it is interesting to explore these dynamics in the city.
Yeah, thank you for reiterating that. So just to kind of summarize, the air temperature is just the temperature alone of the air, and the days are summarized up above here for how many days exceed that historic maximum or days that exceed that historic minimum. And then the air heat index includes humidity, and that's really more so what it feels like for the body. So if you see that in your weather app feels like, that is air heat index. Thank you, Mehdi, for clarifying that. So we could kind of compare and see that it says that Hoboken experienced 22 extreme heat events. So like days that exceeded 95 degrees Fahrenheit in terms of what it feels like, in comparison, say, to the Upper East Side, which only experienced 5 days. So we can see that the urban heat effect is kind of much stronger, maybe experienced here in Hoboken in relative comparison to the Upper East Side. And that might be for a variety of reasons, maybe because the Upper East Side one is like adjacent to Central Park. So it's much cooler with all the vegetated area and grass. So that's like kind of maybe a way to kind of illustrate how to compare some of the different station data. So exploring the data in both the weather stations and the neighborhood aggregations, we also provided a bunch of resources. So this is great that we can dig into all the data, but what can we do about it? How do we prepare for urban heat? There's a number of New York City resources that are linked directly from this website. They're kind of scattered links all over. We wanted to provide all this information in one consistent location. And of course, some national level resources as well from the CDC or the sort of National Heat Health Information System Organization, or to learn more about, how the effects are are more vulnerable for like elderly populations who they're like maybe at higher risk for heart disease issues that are kind of exacerbated during heat events, as well as kind of a directory of heat advocacy groups. So these are folks who are doing advocacy work in the urban heat space. So if you want to get involved or kind of connect with some of these organizations, this is kind of a resource for that. And then, of course, really to make all of this data available. So if you want to download the shape files or the kind of tabular data from the vector perspective, you can download all of that from the Outdoor Heat Exposure Index, and that'll have breakouts for each of those individual static variable values as well. Or you can download each of the individual raster layers. And again, these are kind of pre-processed so that they're at a manageable file size and resampled at like 1 meter resolution, most of them. So yeah, you can have one place to download everything, one place to explore all of that urban heat data. And then I will kind of go back to the deck.
For example, mean radiant temperature. If you want to calculate mean radiant temperature using Solvay, we have how many? Maybe about 60 tiles. We just broke down the city to 60 tiles. For each of those tiles, you might need to spend like 3 or 4 hours for the processing time. So,
And that's only the final step.
not only
There's the
the
intermediate step that takes about 24 hours.
24 hours. So we basically took turns and I went out, did those tasks.
Over 2 months.
Yeah, and so that layer you cannot find anywhere else. Like here is just one click away from having it, and that was one of the objectives for us is just this should be very very easy to download. It's just like if you go to some of the open data, and there are you click over there, explore. I teach urban data, and I teach GIS, and I have to teach the computer to my students. Like this website is slightly different. That's that's the API here is it, but here is just like very easy. Just go to the download page, you find it, you download it. It is just in your download box. So and you can use it. And we have explanation about how the use cases, how it is generated, how you use it. So usually we try to remove those barriers from having this data sold. And it is just like create some reports, and you can just have a nice and neat report what you did.
Yeah, and the last thing I wanted to mention is in order to make all of this information a little bit more accessible to, say, less data savvy analysts. So if you're somebody who just cares about the urban heat information in your neighborhood, you could download like a report of this as kind of a print screen layout of, say, go to that weather station that's closest to your neighborhood, or download a profile of specifically your neighborhood, and it'll like kind of print this in like a print that like PDF it, whatever, print it in a print friendly format, for you to be able to disseminate that information and, you know, bring to a community board meeting, and share that information with others, to, you know, start the discussion about, hey, the data says this, we need to advocate for more permeable spaces, or plant more trees, or maybe talk to your building manager. My roof is a dark roof, we should paint it white. There are many like little incremental changes that you can do. And we're hoping this is a resource to use as advocacy in that sense.
We just finished this, but really, I mean, we are not still finished. I don't think we can say finished. This, we really pushed it in the past couple of months to get to this point that it is functional.
Yeah.
There are a few things that, yes, we still have to fix. There are a few things that we want to add, but we are working on this as we go. For the majority of the work is done.
Yeah.
It's ready to use.
So we're happy to take any questions. Otherwise, we can like, maybe you're welcome to open up your laptops and go to urbanpeace.nyc. And maybe we can do an exercise of like, you know, finding information in the portal. Yeah.
How are y'all thinking about, I know you said this is just newly completed for this version. How are you thinking about update cadence based on new data? We are working on the update. So this data so far is between 2013 and 2023. All that is ready. But we are working with BetaNYC to basically have some dedicated resources and prepare some data for 2024 and 2025. So we are hopeful that at the end of summer of 2025, the summer just coming, we can upload new data. So we are working on that, but unfortunately, we don't have much resources. You know, this project was really done by very, very limited resources. So we have to piece together some of the funding here and there, you know, and we'll see how it goes forward.
Yeah.
This is an amazing effort. Thank you so much for sharing this. I wonder if you've started thinking or have anything going on, looking at the actual effect of some of those potentially heat mitigation strategies like cool roofs on the actual air temperature, for instance, and thermal comfort.
Right. So we built two models in order to let's just let me come closer to the microphone here. I might be too far from the microphone. Sorry, we'll just go behind me.
You want to go into?
So we built two models. One model connects trees, the type of land cover, like permeable, impervious surfaces, buildings, and cool roofs to surface temperature. Basically, the first model, there are some predictors, and you are predicting surface temperature. The second model takes that surface temperature and connects that to the air temperature using, again, another algorithm, another random forest algorithm. So what we are doing here, we are just creating a chain reaction from whatever you're changing in the land cover to the surface temperature, and from surface temperature to the air temperature. Because we have that model, we can move the knobs and just say, what happens if we had 0 tree cover? What happens if we had 0 cool roof? And we can generate now the new air temperature and the new surface temperature based on that.
What is the height of the air temperature that you're modeling
Two-
for, and
up
to validate? I just curious.
2 meters, and we got the air temperature from weather stations. And weather stations usually have the 2 meter height with air temperature. So the algorithm is pretty well. Can you go to the air temperature layer, please?
Yeah. I also want to highlight there's methodology notes in the downloads page. So if you have more questions, you can hopefully that will answer some, but we can go into.
You have to also write papers. After this comes writing. to convert to some publications,
you can't
and
even
people have the methods and details. But so the air temperature is pretty good. I compared this with MacroNet, a network that was not used for training the algorithm. So it was a different data set was used for training. So the MacroNet is actually the algorithm is pretty good. The problem that I suspect is on the water side, because our model is really sensitive about wind and surface temperature values. Because the surface temperature of water is much lower than the rest of the landscape, you might see some hard edges on the waterfront. And that we don't have a data set to validate this with, to have a transit of air temperature from coastline all the way to the, coming into the land. So what we need to do is collecting raw temperature data, perhaps in the summer, and identifying those days the satellite is flying over. And because for those days, we can have a model air temperature. And then having a transit of reading from the coast based on the wind direction and speed to understand how that transit is changing.
So this is modeled air temperature.
It is modeled.
It's not extrapolated. So you have separate weather station, air temperature, and model.
The weather station, we didn't touch it. But we just basically, we dumped it. And, but this is the model air temperature last year.
But I do want to note the weather station data is private, so you cannot download the weather station data.
But you can,
Unfortunately.
yeah, but you can get the profile. You can capture the profile, but we are not allowed to share the CSV of the weather station because, it is you have to pay to get that, and we are not as a user of that, we are not able to redistribute that data. There's a licensing problem with that. So, but the profile is available. Most people will care about that profile.
Yeah, and I know it's difficult to see on screen, but maybe you can trace this boundary line that's where the land is, and that's what maybe you were trying to describe in terms of the edge condition in the raster for the air temperature.
Was a question, Sean?
Sure, thank you. This is really great. My question is, have you considered adding or incorporating the measurements of large scale green spaces around? I understand this tool is built for sort of the neighborhood community board group, but I think an important piece of the advocacy there, right? We all know the benefits and the ecosystem services of those places would be to kind of show that on this in some way. Have you considered that?
Yeah, we are one step away from quantifying that impact, really, right? So, and what we need to do when it comes, for example, to Central Park or to Prospect Park, these really big body of green space, is we know how that is impacting our modeled air temperature. What we need to do is converting that, in a scenario, converting that to just some impervious surface, for example, or the average landscape of the rest of the city, and see how the air temperature will change. Subtracting that from our air temperature here would be the benefit of anything. It would be benefit of the park in that case, or you can do that for full roofs, or you can do that for trees, changing landscape with impermeable surfaces, for example. So basically, we build a model that now we can play with the knobs. We were so busy with building the model, we haven't really started building those scenarios, but those are the next steps for us.
Awesome.
Yeah, this is kind of picking up on that previous question, but first of all, it's an excellent tool and it seems very user-friendly.
Thank you.
So thank you for presenting it and building it. I'm just curious if you think that there is potential for mapping the technical potential for these different surface interventions can go. I think it's really important to be able to understand disparities in heat exposure today on the basis of where permeable and reflective surfaces are. But I'm just curious if you feel confident that maybe you have the data or the methods necessary to then take the next step in terms of identifying priority locations for installing those features in the future, not just on the basis of land cover conditions that are amenable to that, but on the basis of these different social or demographic
Right.
priorities on the basis of heat vulnerability for different populations.
Right. In your question, there are a few important issues. Let me just draw those and address one step at a time. There is a policy implication for sure. I'm a planner by background. That's why this project is, we really wanted to focus on the process of planning. So, yes, and we have we don't have the resources, but we have everything else: motivation, inspiration, and everything to build a scenario planning model. And the scenario planning model would be giving the user some capacity of changing the landscape to see how things change, right? Giving the user the capacity to what happens if you increase tree cover in your neighborhood, if you have a new park in your neighborhood, if you have more cool roofs in your neighborhood. How would that urban heat landscape change, right? So yes, we want to move to that direction. However, I think we have to be really careful. Those are all policy questions. And those are all, there was another presentation this morning about trees and, people, Michael Triglia and the city were presenting the new tree cover product that they are creating. And there are questions there, like, how can we increase tree canopy in the city? And those locations are limited locations. And those locations, there are some criteria. Department of Park just goes through a long checklist to decide whether they want to plant a new tree here or not, right? I think we don't want to really just create some situation that you can plant with, creating an illusion of you can plant trees everywhere. I think that's not the case, right? But we want to be able to provide a situation that we know that Forest for All plan in the cities is the objective is getting to 30% tree cover in all neighborhoods. We want to be able to provide insight what happens if we reach to that 30% goal. How the landscape around you would change. The second issue in your question was how this is impacting different people in different neighborhoods. And that is a very complicated question to answer. The city is trying to work on it with the heat vulnerability index. So let me just give you some background on that. We talked to some folks at the Department of Health, and they have the heat vulnerability index. The heat vulnerability index is based on health issues, socioeconomic variables, all the vulnerabilities that we know it is, evident in so many neighborhoods. So we did not want to create another heat vulnerability index, although technically we could. We had more sophisticated heat data to incorporate in that. The reason is we didn't want to create two different heat vulnerability index. And I had this example, this saying, borrowed from someone else, that if you have one watch, you know what the time is. If you have two watches and they're different, you don't know what the time is, right? So someone has to so we didn't want to bring something else here that creating, and so many of these things, when you build it, you have to make decisions about the subjectivity of that. What is the weight of trees compared to the surface temperature? What is the weight of surface temperature to mean radiant temperature? What is the weight of mean radiant temperature to other? So there are so many decisions to make this, and we didn't want to be in a situation that we are creating something that the city finds it different with their heat vulnerability index. And so we decided we are not doing that task. That task, we can let the city and the officials to do those things, and we can really focus on the outdoor heat exposure, which is relatively, the science is transparent. So we don't have to really worry about those issues.
Yeah, the other thing I want to add to that, to your question, is Mehdi's been having also discussions with the mayor's office of climate environmental justice, MOCEJ, and when we think about who is the target audience, MOCEJ would be kind of the target audience for this scenario planning tool. They really want to be able to assess, and like Mehdi said, have the realistic constraints of what areas can we actually implement improvements to, say, permeable surfaces, or where can we plant new trees, because that's not everywhere. You can't plant a tree in the middle of the road. You can't, there's only so much that we can change. So I think one aspect of like the scenario planner would be to kind of do that spatial analysis of identifying what areas are kind of like within city property ownership that they have control over, or maybe there's incentive strategies for like other parcels. So like the constraints of that, but then also number two, Mehdi kind of touched on this, but I want to reiterate that like, once you identify those areas that are potential that could be improved, of course, you want to do your vulnerability analysis as well to understand and prioritize the neighborhoods who need it most, from a socioeconomic lens, from the heat vulnerability index lens, to layer that factor in. But then once you have an idea, like, okay, we've identified these 5 places that we can implement, say more cool roofs or more trees, planting and permeable surfaces, then like this model that Mehdi has created for the like to process all the data, the scenario planner will then take that new input, like pretend that's the new urban context, and then generate a projective scenario of how that might improve, how much that might improve, like the radiation in the space, or kind of like that end result. Would it, in a tangible and meaningful way, affect like the mean radiant temperature or the surface temperature? Would it come down, or is that level of investment in those identified areas like not really giving us the return that we're looking for? So it's kind of a cost benefit analysis tool for that scenario planner as well.
Yeah. So we are also curious to hear from you. I see some of you have your laptops open. I wonder if you had the chance to open the website. Any feedback? We appreciate anything that you want to see, don't see, or you think, anything.
Well, I found the interface and that kind of clicking around on it.
Yeah.
Really intuitive, easy to use, so thank you for that.
That's BetaNYC's work, so.
Yeah, so it's very fast.
Yeah.
It relaxed it as well.
Yeah.
One kind of like roadmap question. One area that I'm dealing with a lot is building decarbonization these days, and extreme heat is playing into that a lot in terms of how that tends to impact the way we need to increase how we heat and cool our buildings and moving forward, especially as we try to comply with Local Law 97. Have you guys looked into really integrating other data sets like Local Law 84 and just kind of understanding trends between heat and building energy loads?
Not yet. We haven't really explored those.
Why it's a roadmap question.
Yeah,
no,
I mean, not in the context of this project, but now I work at MIT in a research lab, and I have some colleagues who are working on energy performance modeling from that perspective, and they're kind of mapping like visual imagery of streetscapes and AI, like to process images, and from the imagery you can kind of identify what heating or cooling like systems exist on those existing buildings, and then like project energy modeling for like citywide. I mean, that's still like research in progress, but I'm saying like that work is being attacked in like other directions, not necessarily the context of this project. So I think that's also what's challenging, is like you kind of working in this space, you kind of sometimes have to narrow your focus and your research scope. Yeah, we can't do everything, but we can collaborate with those other.
One step at a time.
Yes.
Again, I see that, we are out of time. So I wanted to thank you everyone for coming and for all the great comments and encouraging feedback. Thank you so much.